Okay, I'd like to do a second little demonstration of how the Irregular Tuning Maker program works. So with this one, I'm not going to go into like the details of all of the parts of the UI, which has changed a little bit since the last video, but I'm going to go through two examples of scales and try to show what's interesting about it and how it behaves and how you can try to control it. Okay, so we're in 12 Edo space now. I'm going to go up here. I'm going to start with a scale which is just comprised of the notes C, D, and A. So not really a scale, but I think it will be useful to understand how this system works. Okay, so we've got the notes here, C, D, and A. Obviously, you can change the setting to cents, and you can see these in cents as well. Okay, and I've got my weight function as uniform, so the weight of all of these intervals is the same, always just 1. So I'm going to press make. And there is our tuning of the scale, C, D, and A. So now let's move over to a spreadsheet so we can analyze how this tuning tunes this scale. Here we can see our tuning of C, D, and A. This tuning contains 3 distinct intervals. It contains a major second, a perfect fifth, and a major sixth. So these are their ideal tunings. They come from just intonation, obviously. Here you can see the size of each of the intervals. The interesting part is the error. The error is all exactly the same. For a 3-note scale, it's very easy to make the error be the same. It would be more challenging. In fact, it may even be impossible, I'm not sure, for a larger set of notes. Here you can see what's interesting about the tuning system is it's able to balance out the error perfectly. Now you might be thinking 7 cents error on a perfect fifth is pretty unacceptable. So in this kind of context, you might want to make the weight of the intervals be not uniform. Okay, so back in Irregular Tuning Maker, I'm going to change the weight of this interval here. Remember, this interval was the fifth. This is also a fifth, by the way. It's mirrored across the diagonal line going down from the top left. So I could also change the weight here, but I'm just going to change it here. I would like this one to be twice as large as the other 2 intervals. I could set these to 0.5 and 0.5, but there's a better way to do that. Instead, if I set them back to uniform again, I can just set this one to 2, but now the normalization of the weight relationships will set the other intervals weights to 0.5. There we go, we've got our 0.5s here. Okay, so I'm going to make the tuning again. Did that work? Yes, that did. Okay, so here is our tuning now in cents. So let's move back over to the spreadsheet. Here is our non-uniform tuning of CDA. It's the same as before. This is what's different, the size. So you can see now that the D is a little sharper in this tuning and the A is a little flatter than before, which has led to a much better perfect fifth. I think most people would be satisfied with this fifth. And here you can see the error, so you can see exactly what's happened. So when you've got 3 notes, setting the weight of some interval to be double the others, that's reflected in the error. So you've got quite a fine-grained control here over the tuning when you're using the Irregular Tuning Maker. But obviously most scales don't include just 3 notes. So I want to show now a familiar example of a tuning with more than 3 notes. Okay, back in Tuning Maker again, I'm going to show that example now. So here's what I'll do. I'll start by going to 12 Edo, and I'm going to increase the range up from 1 octave to 2 octaves, and I'm going to add a couple of notes as well. There we go. Okay, now the clever thing that I can do here is I can press Control and I can select notes, and if I press Control, then it will select all of that note that it finds. So this is C, say we're in the key of C major. I'm going to select C, and now if you look down here at the selection boxes, it shows you we've got 1, 13, and 25 selected, which is 1, 13 here, and 25 here. So that's what we want. And then I'm just going to select all the other notes, D, E, F, G, A, and B. And then I'm just going to select one more note here, the D flat. It doesn't really matter, but that's what I'm doing. It's just basically just for the way it will look on the screen. Okay, and then I'm going to press Save As, and I'm going to save this as, let's save it as 2 major. Okay, because it's 2 octaves off the major scale. Do you want to replace it? Yes, I would. Okay, good, and zoom back down again. Now I'm just going to go through and tweak this, and this is one of the benefits of Irregular Tuning Maker, is it's very tweakable. So I think for this tuning, I don't want my minor sevenths to be this value here, so I would like them to be 9/5. I can just type that in. Great, that's all done. That's all I wanted to do. So I've got my weight on arbitrary, and I'm just going to change that to uniform because I want everything to be uniform weight here. And I'm going to click Make. And here is our tuning, so let's analyze that now. Okay, here is our tuning of the C major scale. Octaves are impure here, and they're also impure in slightly different ways as well. So you can see that the octave between C and C is sharp, and here it's sharp again. It's sharp by about 3 cents here. So if you were looking at that and thinking, that's not very good, remember that you could do the same thing that we did with the CDA example. You could just weight the octaves to be more important to get them in tune than the rest of the notes. Obviously that would have a knock-on effect on the rest of the tuning, but it's something you could do, and I would consider doing that if this was a tuning that I was using to make some music. Another thing to note is that we have like multiple tunings of the same interval. So for example, this is the tuning of the major third from C to E, and that's almost pure, right? I think that's like about a cent out. But if we were to take the tuning of the major third from G to B, we would not find the exact same tuning. So let's take a look at that tuning. There we go. You see now it's about 1.5 cents sharper. And in fact, you would find that for every interval. I don't think you would find many repeated tunings of the same interval. So that's a feature of this irregular tuning system, is that you've got different tunings of almost every interval. Okay, so going along here, we've got our minor second going all the way up to our double octave and the ideals to the right. Here's the interesting thing, is the average size. Obviously the average size is not the most useful metric of the tuning. You would kind of want to know what the worst is and what the best is, or at least what the average error is. So that's why I've put that here. So the average error of the fifth is about 3 cents, and so that's the error from the ideal. You might be thinking, okay, well then maybe there's some like really terrible fifths and some really good fifths. Well, no, because you can see the deviation of the error is low as well. In fact, you won't find any big deviations except for the tritone. But to be honest, who cares? Because the tritone is usually treated as a dissonance anyway in diatonic music. So that's not a big problem. If it was a problem, you could just weight the tritone more if you wanted that to be more in tune according to this ideal. So the final thing I'd like to do is I would like to finish with some music made with this tuning of the C major scale, so you can hear how it sounds in a musical context. I'd love to know your thoughts on any of the things I presented here, the system itself, or its application to music, or any questions that you have about how it works. I realise that I've still not explained exactly how the algorithm works. The reason is that I don't have much faith in myself as a communicator, let alone a maths communicator. But if there is any interest in explaining the maths behind it, I can. Otherwise, I'm just going to keep uploading music tuned using tunings made in the Irregular Tuning Maker. But yeah, I think that's everything. Please enjoy this music tuned to an irregular tuning of the C major scale.